What is going on, guys? Welcome back. In this video today we're going to learn about a Python feature introduced in Python 3.10 called structural pattern matching. So let us get right into it. Alright, so structural pattern matching is not very new. It was introduced in Python 3.10. I think the current version is Python 3.12, so it's already 2 versions old. And a lot of you guys might already know this feature and might have already used this feature, but I also think that a lot of you guys don't really know what this feature is about, because a lot of people use it as a switch case in Python. And it can be used like that, and it does work like that a little bit, but it has another purpose and another use case which we're going to talk about in this video today. The feature we're talking about is the match case feature. So what you can do in Python is you can have some value, and the value can be, for example, a string. Let's say it's hello, and then I can use something called structural pattern matching. I can say match, and then I can say I want to match the value, and I want to have certain cases for this value. So I can say the value can be hello, for example. This is one value that the variable value can have. And in this case, I want to do something. So I want to print, for example, the message hello world or whatever. Then I might have another case. If this value has the value exit, for example, I can react to it by exiting the script. And you can see that this works in a very similar way to just saying, okay, if value equals hello, do something. So pass. Elif, if the value is something else, so exit, for example, do something else. And then I can have a default case where I do something else, and I can do this here as well by just saying case and then underscore or some variable name. It doesn't really matter. You can call this whatever, and then you can do something else here. Usually what you do is you use an underscore to indicate that this is the default case. If nothing, none of these works here, so we're going to just go to the default case. So that works pretty similar to a basic if-else statement. And I can run this here now, and you can see it says hello world, and I can change this to exit, and you will see it just exits the script, and I can change this to, to something else. And when I run this, okay, I'm passing, so let's print unknown command. In this case, it prints unknown command. So what's so fancy about structural pattern matching? Now, it gets interesting when you're actually doing pattern matching. Right now, we're just asking for values, but we can also ask for patterns. So let's say I have a different use case now. Let's say I pass a tuple or a list containing division values. So let's say I want to pass a list of numbers or a tuple of numbers, and I want to divide them. What I can do is I can say division numbers is equal, and I can define a tuple here with values like 5 and 2. And then I want to take these values and perform the division 5 divided by 2. Now, this is a trivial use case, so this is not necessarily the most useful thing to do here. But what we can do now is we can just say match division numbers, and I can define the case that I have some values x and y. And the values x and y, if I get them, what I want to do is I want to print x divided by y is equal to x divided by y. So I can do it just like that. And if I get something else, I can just define a default case, and I can say something like invalid input or something like that. So when I run this right now, I get 2.5 as a result. Now, if I do something else, if I, for example, just pass 10, I'm going to get invalid input because that's not a tuple of x and y. Also, if I say 5, 2, and 3, I will get invalid input because that would be a tuple with 3 values in it. So that right here now is one specific case. Now, I might want to define another case where I say, okay, if y is 0, I want to handle it differently. So what I can do is I can define a case up here and say, okay, I can have a tuple x and the second value is 0. In this case, I want to say cannot divide by 0. So you can see I just defined a pattern that I want to match, x and 0. In that case, divide by 0. And you can see I still have the invalid input. So now if I just run the ordinary division, I get 2.5. If I set this to 0, I get cannot divide by 0. If I do that without this case, I'm just going to get the exception because it's going to recognize this as x and y, but y is 0, so you cannot divide by 0, and you're going to get the exception or the error, 0 division error. So that's a very simple thing. What we can also do is we can define, and by the way, this is one thing that's important. It's important which case comes first. So the value or the combination here, 5, 0, matches both cases. So 5, 0 is x and 0, but 5, 0 is also x and y, which means that if this case comes first, it's going to recognize it first as a match, as a pattern match, because it is a pattern match. 0 is also y. And now I'm going to get the 0 division error. So you want to have these cases before that. But what I can do now also is I can say, what if I enter more numbers? And I can define a case, and I can say, okay, if I have x, y, and other values, and how I do that is I say asterisk other, for example. What I want to do here now is I want to say, okay, I'm going to say division result is going to be equal to x divided by y. And then what I want to do is I want to say for number in other, what I want to do is I want to say division result divided equals number, and then I want to just print the result, so division result. I can do that, and now what I can do is I can say 522, for example, and I will get 1.25, and I can continue to do that with more values, and you can see that the division keeps going. Now, the problem is, again, I can now introduce a 0 here, and I will get an exception. So what I can do is I can add conditions. I can say x, y, other if 0 not in other and y is not equal to 0. That is a pattern match right here. I have two values and then some more values, and if 0 is not in other, I can actually also define this just as x and other, but yeah, we can do it like this as well, just so you see it works. But you can also just say x and asterisk other, and then you can say if 0 not in other, that would also be fine, and then you just divide x by all the values. There's also a possibility, but this is also something that you can do. You can add conditions. Now I can copy this, and I can say, okay, if I have this pattern match, and I can say y is equal to 0, or 0 is part in other, then I can also again just print cannot divide by 0. And then you can see cannot divide by 0, but if I change this to 2, there you go, we get the division. So that is the power of pattern matching. And the good thing is you can also, actually this is probably, this is important here in this case at least, you can use an underscore to basically indicate that it doesn't really matter what x is, because I don't need to call this x here if I'm not using x. I can just say this is some value, because we're not using it anywhere. If there's some value and then I have y and other and these conditions are met, then do this. In this case here I'm using x, and in this case here I'm using x as well, so I'm going to keep them. But yeah, this is how you do the pattern matching in this case. Now, one thing that you can also do with that is you can check for types. Now I'm just showing a couple of use cases here. If I have some value and the value is, let's say, a string hello, what I can do is I can say match value, and then I can use types to match the type of the value. This can be useful if you have an input to a function or a parameter to a function, and since Python is dynamically typed, you don't know what the type is going to be, so you can check for the different types. And how you do that is you can say case string, and you need to call the string function, so the typecasting function, and then you can just say, okay, it's a string, and the string is whatever the value is. And then you can say something like, what if it's an integer, and you can use a pipe symbol to say or a float. So if it's a numeric value, what you can do is you can just, for example, take the value and square it. This is one thing that you can do with that. Yeah, so that would work. And what we can do now is we can go, or actually we don't have to do anything. We can just run this, and you can see string hello. If I change this to 20, it's going to be 400. If I change it to 90.3, it's going to be that. Now, if I change this now to, if I add a case for default, I can say unsupported type or something like this. And then if I change this, for example, to a list, it's going to say unsupported type. So this is also something that you can do. Now, finally, I want to show you a use case that is quite interesting. We can have a command line interface. So I can say the command is the user input. So I can just ask for a command. And then what I can do is I can allow for different patterns of commands. So I can say, okay, simple case is I have the, I match the command now, but I want to split the command. Why do I want to split the command? To allow for different positional arguments. So I split the command on white spaces, and then what I do is I say, okay, match command split, and then I can define a simple case. For example, the command could just be hello. Now, since we're splitting, I need to pass this as a list here. I need to define it as a list. So it's going to be the one argument hello, and in this case, I can print, for example, hello world. But I also want to allow for parameters for certain types of commands. So I can say, for example, there is a command say followed by a message. And what I want to do in this case is I want to print the message that was passed here. Yeah, so that also works. Or we can also maybe say asterisk messages. This would also be a thing. And then we can do something like I have the command add, and I take the two values x and y here. Or basically we can do it even more generalized. We can say add, and then I can say numbers, so asterisk numbers. And then what I can do is I can say print the sum of the following list comprehension int n for n in numbers. And then of course we need to call this sum. And then I can have a default case which says unknown command. So then we have this interface now. I can say hello. I can say hello again. I can type something else, unknown command. I can say add 10, 20, 30. I can get 60, and then I can say something, for example, test, and I'm going to say test. All right, so this is structural pattern matching in Python, a very useful feature. So that's it for today's video. I hope you enjoyed it and I hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.